science isn't just facts, it's stories. Meet beryllium. It makes emeralds glow, satellites survive space, and jet fighters stay sleek. And if you breathe it in, it slowly ruins your lungs. Welcome to element number 4, the don't inhale me metal. We've already met hydrogen, helium, and lithium, baby steps on the periodic playground. Now comes beryllium, the quiet kid with a glittering secret and a mean streak. Rare, light, beautiful, and toxic. Basically, the Angelina Jolie of elements. On paper, it looks harmless enough. Atomic number 4, silvery white metal, lighter than aluminum, and stiffer than steel. Sounds like a dream material, right? Except there's a catch. It's rare, expensive, and will absolutely wreck your lungs if you mess with it. Nature's way of saying, you can admire me, but don't get too close. The name comes from the Greek beryllos, meaning precious blue-green stone. Yes, that's emeralds and aquamarines. So the same element that NASA uses to build spacecraft is also sitting quietly in Grandma's jewelry box. Science loves irony. In the late 1700s, French chemist Louis-Nicolas Vauquelin was poking around emeralds like any respectable scientist does on weekends. He found a new Earth inside. At first, people thought it was aluminum. Turns out it was something stranger, a whole new element. At first, they called it glucinium, from the Greek for sweet, because beryllium salts taste sugary. And yes, chemists of the 18th century were licking rocks. Different era, different OSHA rules. The sweet name didn't last, probably because glucinium sounds like a diet soda. Instead, the name beryllium stuck. Cleaner, sharper, less confusing. Meanwhile, researchers noticed something alarming. Workers handling beryllium dust got very sick. Chronic beryllium disease can ruin your lungs with just a pinch of exposure. Beautiful element, terrible roommate. Here's the kicker. Despite the danger, we still use it. Because the resume is unbeatable. It's ridiculously light and insanely stiff. Two traits that normally don't coexist. Strong stuff is usually heavy, and light stuff is usually weak. Beryllium cheats. That's why aerospace loves it. Satellites that don't sag, jet fighters that stay rigid at Mach speeds, precision instruments that don't warp. NASA is obsessed. Even golf clubs briefly flirted with beryllium, until someone asked, "Do I really want lung disease from my 9-iron?" Answer, no. NASA, though, never broke up. The James Webb Space Telescope, its giant golden mirrors are made of beryllium. Light enough for launch, stiff enough to keep shape at freezing space temperatures, and shiny enough to make astronomers cry. An element deadly to lungs is also letting us see the birth of galaxies. Chemically, beryllium sits in group 2 of the periodic table, the alkaline earth metals. Same family as magnesium and calcium, but the weird cousin. It doesn't dissolve in water like its relatives. It's amphoteric, acting acidic sometimes, basic other times. Like a friend who can't decide between tacos or pizza. Its small atomic radius means it hogs electrons, making bonds unusually strong and covalent. Translation: beryllium is a chemical overachiever, stable in ways its siblings aren't. But it's an overachiever with a bad attitude. Back in the 1940s and 50s, fluorescent lamp factories were basically beryllium dust buffets. Workers inhaled it, got sick, and some never recovered. It was a harsh wake-up call. Today, machining beryllium is done in sealed zones with hazmat gear and filtered air. Handled with extreme caution. Despite the risk, it's too useful to abandon. It's transparent to X-rays, which makes it perfect for medical imaging windows. It handles nuclear reactors, precision instruments, and particle physics experiments. Smash protons into beryllium, and you get showers of neutrons. Even subatomic chaos obeys the beryllium is extra rule. It's rare, though. Less than 0.0004% of Earth's crust. Rarer than a functional office printer. Found mostly in minerals like beryl and bertrandite, mined carefully so dust doesn't spread. And yet, we keep digging it up. Because it's irreplaceable. Strong, light, and stable in extreme environments. The Swiss Army knife of toxic metals. Now back to jewelry. That sparkling emerald ring? Its glow comes from chromium atoms sneaking into a beryllium lattice. Aquamarine's blue is courtesy of iron in the same structure. You're literally wearing a totic aerospace metal every time you flaunt a gemstone. Of course, jewelers don't advertise that. Forever love, with traces of lung-destroying metal, isn't exactly romantic copywriting. Still, it's beryllium's crystal architecture that makes those stones unforgettable. So let's tally this up. Beryllium makes gemstones sparkle, aerospace engineers drool, particle physicists smash things, and doctors peek inside bodies with X-rays. All while being rare, expensive, and dangerous to handle. The paradox of element 4. Beautiful and brilliant, but unforgiving. Hydrogen lit the universe. Helium kept the stars burning. Lithium charged your phone. And beryllium? It's the element that sparkles, soars, and slaps you with a health warning. Next up is boron, the element that secretly makes your laundry cleaner and your spaceships tougher. Stay tuned.